Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials version 6 course from the Cisco Networking Academy, or the Networking 2 course from AACC, and this afternoon's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 7.2.1.7, where we're now going to be taking a look at named standard IPv4 ACLs. So in Activity 7.2.1.6, we looked at numbered standard IPv4 ACLs. Now we're going to look at how we would create ACLs that have names in order to provide us a little more flexibility and ultimately more clarity when we're looking at the ACL. Because with numbered ACLs, and especially with its standard or extended, right? If you look at the ACL and all you see is the number, it might not give you too good of an indication or too great of an indication as to what that ACL is actually doing. So let's go ahead and dive in here and take a look at our scenario. It looks like everything has been configured already from an IP perspective. Let's verify connectivity. So all three workstations should be able to ping the web server. So let's test from PC 1. And again, always a good idea before you start locking things down is make sure that it functions first and then start to close things off. So 192.168.100.100, and we should have connectivity. We've got a PC 0, and I can honestly say I don't remember the last time I saw a PC 0. It's usually 1, 2, and 3. So let's go ahead and ping 192.168.100.100. All right, so we can get to the web server, and the file server is 200, 100, and that should work without any issue. You can see it worked over here, getting to the web server. Now let's check the file server, 100 or 200, 100. So it works on both, and then from PC 2, let's ping both the web and the file server. So ping 192.168.100.100. And you can see those echo requests are making their way over to the servers, and then the echo, the ICMP echo reply is making its way back to the PC. All right, so we have full connectivity. So good news. Now let's go ahead and move on. So configure a named ACL. And first let me say, okay, so the senior network admin has tasked you to create a standard named ACL to prevent access to the file server. All clients from one network and one specific workstation from a different network should be denied access. And so it's down here as to how they're going to break that out. Now, take a look at that. That is a great access list name right there. File server restrictions, right? Or it could be access deny file server, okay? But again, it gives us a lot more flexibility when creating the ACL to make it so that if someone that we're working with is coming behind us and taking a look and seeing, hey, what's this ACL do? It's very, very easy to see and to sort out. All right, now there is only a single layer 3 device here. Remember that standard ACLs are nothing more than packet filters. They're simply access control lists that filter traffic based solely on the layer 3 source address found in the IPv4 header, right? So let's go ahead and get on to router 1 here. And let's enlarge our window a little bit, give us a little more room with which to work. We'll go to the CLI. Now, one significant difference between creating, and let's get from user executive privilege exec and then into global config first with the enable command and the configure terminal or conft commands. So one major difference between standard ACLs and extended ACLs, and the same is true. And actually, let me rephrase that. A major difference between numbered ACLs, whether they're standard or extended, and named ACLs, right, whether they're standard or extended, is how we create them. Remember, for a standard numbered ACL, I type in access list and I pick a number from 1 to 100, from 1 to 99, And then remember we saw that expanded range of 1300. I'm going to have to pull this back up. Where are we at here? I think it was, where's it at? Yeah, 1300 to 1999, right? And then for the extended ACLs, the expanded range is 2000 to 2699. So I would just simply put the number in. You'll notice there's no option here for me to say file server, and what are we calling this? Restrictions, right? It doesn't exist. And so here's what we have to do. We need to say IP. So we have to preface the access list keyword on the command line here with IP. Now, when I do a question mark here, you can see it's going to force me to put in what are you going to do? Is this going to be a standard ACL that's going to have a name, or is it going to be an extended ACL with a name? And let's follow along here on the real Cisco command line with the real iOS. So let's get into global config. So if I was to say IP access list and do a question mark, you can see we've got some additional options from which to pick. But we're focused on standard and extended. So I'm going to say IP access list standard, and I'm going to do a question mark. Now this causes confusion, a lot of confusion with learners, because they see this and you're immediately thinking, wait a minute, you just told me we're doing a named ACL. So how is it that the numbered ACLs are showing up here? Right? We've got the standard range. We've got the regular range for the standard numbered ACL, and then we've got the expanded range for the standard numbered ACL. So why are those there? And let's see if they show up in Packet Tracer, which I'm assuming, we're going to say standard, that they will. And we don't see the expanded range, and that's okay, because it still shows us the normal range, right? But the question again, why are those there? So can I create IP access list standard 1? Yeah, so I can get in here, right? But what am I doing? Does this create standard ACL 1? And let's go ahead and do this. And again, the points aside, right? Because we're doing names, so it doesn't matter. So if I was to say permit host 192.168.20.4, and remember, I could say it like that. I could also, if it's a host, I could say, let's say it's another host on that same subnet, 192.168. This question's been coming in quite a bit over the ACLs. I could do this. Those two statements are the same statement. Again, we've got a different last octet here, right? So different PCs, but they mean the same thing. They're specifically saying, because what is the inverse of that wildcard mask? Yeah, it's the all 255s, right? Which is a /32. That's called a host route, because all 32 bits need to match. And that means it would match exactly that IP address, right? Down to the final bit in that address. So that's two ways right there to say the same thing. Now, you'll notice that I'm in here, I'm typing away permit whatever, and then we're going to go, deny any. So I'm going to go ahead and type end. Now, what does it just give you the impression I just did? Yeah, but where's the name? Right? There's no name there. So the reason that those numbers are there, so let's get back into global config. The reason you see when I say IP access list standard and I do a question mark, the reason I see standard IP access list numbers is because I can go in and edit the ACL like this. So watch what happens here, because you'll notice I see access control entry, or ACE, numbers here that are identifying each access control entry. So what if I popped in here, I go in, I say IP access list standard 1, and I say no 20, and I say end, and I say show access list. Yeah, 20's gone, right? So you can edit the ACLs, and we'll get back into global config with config terminal here. You can edit the ACLs. Standard numbered ACLs can be edited. We just did, right? We just did that. So when I say, and you can see here, standard IP access list 1. So when I say IP access list standard, I do a question mark, you can certainly, if it exists, or I'm sorry, if it doesn't exist and you type the number in, you're basically creating a standard numbered ACL. You can't create a named you can't create a named ACL that has like some sort of a number, right? Even if it's in the range. That is not a name that we're giving it. We're giving it a number. And when you precede access list with IP and you're using a number, it's because you're going in to edit the ACL. So again, I want to make sure I clarify that, because this causes a lot of confusion, because learners will say, well, wait a minute, you said that IP access list standard, that you give it a name and that's how you create a named ACL, but I can create a numbered ACL here with IP access list. This just isn't the conventional way that you do it. And this is used to go in, like I just showed you, and edit things, right? I could add access control entries in there. I could add ACEs into that ACL, or I could delete them, right? But I wanted to make sure I covered that, because that does cause some confusion when you see these numbers showing up here. But we want a name. So we're going to say file server restrictions. And let's hope that showing you that restrictions did not blow up the packet tracer scoring engine. All right, so we're going to allow host 192.168.20.4, and I'm sure that's PC1 maybe, 20.4. So we're going to allow that host to get to the file server, but then we're going to say deny any. So only 192.168.20.4 can get to the file server. Okay, for scoring purposes, the ACL name is case sensitive, and wow, we got 80 points out of that, so we definitely got the name right, I believe. All right, so now the question becomes, as we come over here, where are we going to place it? So what interface am I going to place it on? And what direction is it going to be placed in? Remember, standard ACLs, we want to get these as close to the destination as possible. That is a best practice and prevents unexpected results. So 192.168.20.4 is PC1. So this guy right here is allowed. He is permitted, and let's green light him. He is permitted to get to the file server. Everybody else should be blocked. And so that raises the question. We know it's going to go on router 1. Why would I not put it on this switch here, and this switch here, and that switch there? Yeah, because these are layer 2 switches, right? Layer 2 switches. They don't understand the IPv4 named or numbered ACLs, because remember, the ACL, the standard ACL, is a layer 3 only packet filter. It is looking at the source IP address in the IPv4 header of every packet that hits the interface. These switches here are layer 2 switches that do their forwarding using MAC addresses, right? So they're dependent upon the MAC address to move frames around the network. The router, which is a layer 3 device, is using packets with IP addresses to make its forwarding decisions. All right, so let's close this out. So remember, we want to get it as close to the destination as possible. So that is going to be my guess as to the interface we want to put it on. Because again, there's the ACL. We're only allowing PC1 to get over here. So if I put it here, that would hose up PC0. If I put it here, it would hose up PC2. If I put it here, that means the web server can't get to the file server. So we want to put it there, right, as close to the file server as possible. And again, those statements I made previously as we're talking inbound direction here. And what direction are we going to put this in? Is it going to be the inbound entering the router, or is it going to be leaving the router that we want that ACL to be evaluated? Yeah, it's when the traffic is leaving, because that gets us as close as we possibly can, and it's going to permit traffic that shows up with PC1's IP in the source IP field, but it's going to stop all other traffic from getting to the file server. So let's go ahead and make that happen. Let's figure out what interface is that. File server is 200.100, so it's going to looks like Ethernet 010. All right, so let's pull this up, and let's say do show IP interface brief and 010. I don't think that's the right. So we may have an issue here if I read this right. So the file server IP is 192.168.200.100. Yeah, so this table is listing Ethernet 010. Well, what is Ethernet 010? Yeah, that's PC1 subnet. So that is the wrong interface. So let's see what happens here. What would be the right interface? Yeah, exactly. It's going to be fast Ethernet 01 because that's the 192.168.200.1. So let's jump onto interface fast Ethernet 01 and let's go ahead and apply it. And we apply it the same way, IP access group, but instead of the number, we're going to put the name, file underscore server underscore, let's get this right here. And it is case sensitive. Restrictions in the outbound direction. Now, do we pick up the 20 points? We do. So that is wrong. It looks like these are backwards. Fast Ethernet 01 is not the 20. That is the .20 network. Fast Ethernet 01 is the 200 network. All right, so let's go ahead. All three workstations should be able to ping the web server, but only PC1 should be able to get to the file server. And before we do that, let's say show access list or access lists. And this is the one we're interested in. So there we see our ACL, right? We've got the permit statement and we've got the deny any statement. We could also say, and this is a great command, show IP interface fast Ethernet. Oh, well, they get it right. See, so it's funny. Look, they get it right here, right? That's correct. It's the addressing table that's not correct. All right, and we say this because fast Ethernet 01, where is the access list? There it is at the top. So we can see there's an outgoing access list, right? File server restrictions. So let's save our config and let's check out the pings. Let's see if this works now. So can we ping 100.100? So, and that is, let me make sure it's the file server. No, that's the web server. So I can ping the web server. Can I ping the file server from PC2? The answer is no. All right, so by design, things look good right now. Can I ping the web server from PC0? I can. What about the file server? Should this work? The answer is no. Destination host unreachable. And you can see that this is telling us it's probably an ACL because who is responding here? Yeah, the router is responding, saying destination host unreachable. So it's a possibility that we've got an ACL applied, which we know that we do. So back to the PC1, and this is for all the money. So can I ping the web server 100.100? Absolutely. What about the file server? Yes, I can. Right, so let's take one last look here at the ACL. And you can even see we've got our 8 denies, right, from PC0 and PC2, 4 ping packets each. And then the permits, we've got our 4 matches, right, that came in from that host right there. All right, well, that is going to wrap up packet tracer activity. 7.2.1.7, where we took our first look at named standard IPv4 ACLs, and we also saw that when we type in IP access list standard, and the same applies to extended, if you did a question mark there, you would see that you can put a number in. And that's typically used for editing, modifying, numbered, standard or extended, numbered ACLs. So don't get confused by that. And that is technically another way that you could certainly create an ACL. You saw that we did it from scratch, right? But that number is not a name, right? It's a number. So that's it. Thanks for watching, guys. I'll see you in the next video.